In this video, we're going to focus on section 2.5, which is covering graphing linear inequalities and systems of linear inequalities. So this starts on page 89. So the beginning of the section, it basically talks about what a solution to a linear inequality means. And basically what that means is that you're finding all of the points that make the inequality true. So in this textbook, we encourage the use of the graphing calculator to graph your linear inequalities and systems of linear inequalities. So we're going to do that in this video. So it shows you what your calculator screen will look like when you input your inequality and then when you graph the inequality. So we're going to practice doing that in this section. So let's start with example 1. So example 1 says graph the linear inequality y is greater than 4x plus 4. So when you put any equation or inequality into the calculator to graph, you want to make sure you set your, in this case, inequality equal to y. So you want to isolate y and get y by itself, because in order to input the inequality or equation, you're going to first select the y equals button here. So once you isolate y in your inequality, we're going to put the right side of the inequality, in this case 4x plus 4, in this screen. So we're going to say 4, this is the variable x button here, 4x plus 4. Now, this is an inequality. So if we were to graph this as it is, we would select graph, and we're going to get a line as if it was an equation. But this is an inequality, so we have a region of solutions, not just a line. So let's go back to the y equals. So we want to tell the calculator how to shade. So if we go over here to the very left, so y is greater than 4x plus 4. So that means we want to shade above the line. So we're going to press enter however many times in order to show the top part being shaded. So you see how that upper part is shaded? Let me show you how it would look if it was the bottom part shaded. That would be below, bottom shaded. And this is if you wanted, dots, dotted lines, and so forth. But we want to show the top part shaded because y is greater than. And so now we're ready to graph. So if we select graph, we can see our solution, and it looks just like this picture. Now keep in mind that we don't have the ability in the graphing calculator to shade and to show a dotted or solid line. So keep that in mind. So in this case, y is greater than. So if it's greater than or less than, this line here would be a dotted line, just like the picture is. If this was greater than or equal to, or less than or equal to, it would be a solid line. But that's how we graph. So we can verify the accuracy of the graph by choosing test points. So it can be any point that's not on the line here. We would plug it into the inequality. And then if we get a true statement, then that means that wherever that test point is on the graph, that's where you should shade. If the test point we plug into the inequality and we get a false statement, that means we do not want to shade that area of the graph. So for example, if we choose 0, 0 as a test point, it is not on the line, so it's a good test point. If we plug it into the inequality, we'll end up with 0 is greater than 4. That is not correct. So that is why you do not want to shade this side of the graph. That is why we shade the other side of the graph. Now let's say we choose a point that is in the shaded region, say -2, 2, somewhere up here. If we plug that into the inequality, we would end up with 2 is greater than -4. That is a true statement, so that's why we are shading on that side of the graph. Let's do another one. So graph the linear inequality 2x plus y is less than or equal to 3. So I'm going to clear this. So remember, you have to set the inequality in slope-intercept form or isolate the y. So we are going to do that by subtracting 2x from both sides, and then we'll end up with y is less than or equal to negative 2x plus 3. So now we're ready to put it into the calculator. So we're going to go to y equals, and if you want, you can just clear this inequality from the old problem and then input negative 2x plus 3. Now we need to tell the calculator how we want to shade. So it's y is less than or equal to. So we're going to go over here to the left and we're going to press enter until we show the bottom part shaded. There we go. And now we're ready to select graph. And so this is our graph on the calculator. Keep in mind it should be a solid line because it is less than or equal to. And then you can always check the accuracy of the graph by selecting test points. So in this case, let's use 0, 0. That's my favorite test point to use if I can. As long as it's not on the line, you can use a test point 0, 0, or any test point. So we plug in 0, 0. We end up with 0 is less than or equal to 3. That is a true statement. So that's why that side of the graph is shaded. If we were to choose a test point on the other side of the graph, say +2, +2, somewhere over here, we plug it into the inequality. We end up with 2 is less than or equal to -1. That's false. A positive number is not less than a negative number. So that's a false statement. So that's why we do not shade over here. Okay, let's look at example 3. Graph the linear inequality x minus 3y is less than 6. So first we want to put the inequality in slope-intercept form. We want to isolate the y. So we can start by subtracting x from both sides, and then we have negative 3y is less than negative x plus 6. Then we're going to divide both sides by negative 3. And remember, when you divide by or multiply by a negative, you want to flip the inequality symbol. So we're going to end up with y is greater than now positive 1 over 3 minus 2. So now we're ready to put it into the calculator. So we're going to select y equals. Let's clear this previous one out. And so I'm going to put 1/3 x. I like to put my fractions in parentheses. Depending on your calculator, it may create the fraction for you, but I have an older version here. So I have 1/3 in parentheses times x minus 2. Now, y is greater than 1/3 x minus 2. So I'm going to go over to the left. And I'm going to press enter until I show the top part shaded. Select graph. And then I have my graph of the inequality showing the solution set. Now, keep in mind, it should be a dotted line because it is greater than and not greater than or equal to. But I can't do dotted lines and shade in the calculator. So that is my solution. Let's look at example 4. Now, so we've practiced graphing linear inequalities. Now let's talk about graphing systems of linear inequalities. So remember that a system is just more than one equations or inequalities in this case. So we're just going to graph both of them in one graph and find where the shaded regions overlap, and that will be the solution to the system. So we have y is less than or equal to x plus 3, and then y is greater than or equal to negative x plus 5. So they're already in slope-intercept form, so we can enter both inequalities into the calculator. So we're going to select, let me turn it on, y equals. So let's start with the first one. So we're going to clear this, and I'm going to put x plus 3. And then y is less than or equal to, so I want to shade below the line. So there we go. And let's cursor down to the second inequality. So we have negative x plus 5. So negative x plus 5. And then I'm going to select the shading above option. So this is what my window should look like when I input the inequalities in. And I'm going to select graph. Let's see what we get. So as you can see, we have our graph here, and then we have the overlapping shaded region over here where this cursor is. And as you can see, that's also shown here. It's kind of hard to see, but it's showing you that this area would be where the solutions to the system are. And so you can check the accuracy of your graph by using test points. And in this case, you have to plug the test point into both inequalities in order to determine whether it's correct or not. So they use 4, 4. So it looks like 4, 4 is in the shaded region, overlapping shaded region. So if we plug in 4, 4 into the first inequality, we end up with 4 is less than or equal to 7. 4 is less than 7, so that's true. If we plug in 4, 4 into the second inequality, we end up with 4 is greater than or equal to 1. 4 is greater than 1. So since the test point 4, 4 comes true for both inequalities, that means that this area that has a test point is in fact the solution. It has the solutions for the system of inequalities. Let's look at example 5. So graph this system of linear inequalities. We have 2x plus y is greater than 7 and 3x minus 3y is less than 12. So we need to put both inequalities into slope-intercept form. So to focus on the first inequality, we want to subtract that 2x. So we'll end up with y is greater than negative 2x plus 7. So the first inequality is ready to go. The second one, we want to start by subtracting 3x on both sides. So then we have negative 3y is less than negative 3x plus 12. And then we're going to divide both sides by negative 3. And when we do that, we need to switch the inequality symbol. So when we divide both sides by negative 3, we'll end up with y is greater than negative 3 divided by negative 3x plus 12 divided by negative 3, which simplifies to y is greater than positive x minus 4. So these are the two inequalities we're going to put into the graphing calculator. So we're going to select y equals. Let's clear both of these inequalities. Let's enter the first one. So I'm going to enter negative 2x plus 7. And then I want to shade above because we have y is greater than. So we're going to cursor to the left, press enter until I get the top part shaded. Then I'm going to go to the second inequality. I'm going to input x minus 4. X minus 4. And it says y is greater than x minus 4. So for this one as well, I'm going to shade above. So now this is what the window would look like when I'm ready to graph. I'm going to select graph. And I see that my solutions are going to be in this overlapping shaded region right here. Then you can use a test point to check the accuracy of the graph. So the test point we're going to use is 4, 2. And you can use any point as long as it's not on one of your lines. So if we use 4, 2, that would be somewhere in here. So if we plug it into both inequalities, if we plug into the first one, we'd end up with 2 is greater than negative 1. That's true. If we plug into the second inequality, we end up with 2 is greater than 0. That is true as well. So we know that this is in fact where your solutions are, this overlapping shaded region. Okay. Let's look at example 6. Graph the system of linear inequalities. So we have negative 7x plus y is greater than or equal to 9, and then y is less than or equal to 7x minus 5. So the second equation is already in slope-intercept form, and that second one is ready to go. We need to take care of that first inequality. So these aren't equations, they're inequalities. So let's look at the first one. So in order to get that on slope-intercept form, we're going to add 7x to both sides. So we have y is greater than or equal to 7x plus 9. So now we have the first inequality ready to go. The second one was already ready to go. So now we're going to put them into the calculator. So I'm going to select y equals. Let me clear those old inequalities. And let's enter the first inequality. So 7x plus 9. 7x plus 9. And we have y is greater than or equal to 7x plus 9. So I want to choose the shade above option. Let's go to the second one. We have y is less than or equal to 7x minus 5. So I want to put 7x minus 5. And then I want to select the less than shade below. And here we go. So that's how the window would look for the y equals. Now let's graph it. So remember, the solution is where the shaded regions overlap. And in this case, there is no overlap. And you can see it here as well. They both are solid lines because they're both equal to as well as greater than or less than. But they don't overlap. So whenever that happens, that means there is no solution, okay? There is no point that will satisfy both inequalities in this system. So the answer to this is no solution because there is no overlapping shaded region.